The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome back to Amazing Mechatronics and Young Engineers. Apologies for being a few minutes late. It took me a little bit longer than usual to get home from work. But let's continue with the minimum of fanfare. So let's go ahead and get back into Scratch. Hey Parjit. And I'm going to open up my stuff. I can see inside Space Invaders Division A. I'll give everybody just a couple of minutes to get started up on that. So at about 6:08, we will continue. Okay, so that should be about enough time for everybody to get ready to go. So let's go ahead and take a look at our Scratch again. So the thing is, if you'll recall, we have mostly the makings of a small little Space Invaders game. We have a ship that'll move left and right. It will shoot one laser, bullet, whatever you prefer to call it, before having to wait for it to leave the screen. And we've got an enemy that moves down towards your character. And if you're not just complete garbage at it like I am, you should be able to get rid of him. What we don't have is we don't really have a lose condition though, and we don't really have the means in place in order to include more ghosts. So what we need to do is we need to figure out how exactly we're going to do that. So what do you think the best way to go about figuring out whether or not the ghost is touching the ship should be? Where should we put that code? Got a vote for on ghost and another one for on ghost. Yeah, I would agree, actually. The ghost is probably the best place to put it because we could put it on the spaceship, um, you know, but we've got so much of our logic right now in the ghost. Plus, we can have the ghost stop moving and do all that additional stuff if that ever happens. So why don't we go ahead and throw it in there? So we're going to put in another if statement at the end here. And we're going to say if touching, and in this case, we're going to be if touching spaceship, then why don't we just make it simple right now? We'll just say stop all. And if we test that out, we'll wait for the ghost to arrive at his destination slowly. Could have sped up the ghost, but oh well. And sure enough, there it is. That's a game over because the ghost is touching the spaceship. Makes the game a little bit more difficult because I believe in traditional Space Invaders, it's not going to have that little hangy downy bit on the ghost, and it's not going to have as much of the little pointy uppy bit on the spaceship. So you'll have a little bit longer to resolve the whole ghost being really close issue. But there it is. We got a lose condition, and I guess technically we got a win condition. If you hit the ghost and it disappears, there are no more enemies. So you did it. You win. But let's make this a little bit more, maybe a little more difficult. What we're going to try and do is, put more ghosts. And this should actually be pretty easy to do. What I'm going to do is I'm going to just right-click and duplicate my ghosts until I've got enough of them, and we'll replay it. And if I select them, I should be able to move the ghosts. Now, you might notice that as soon as I hit play, the ghosts are all going to compress back down to 1. And they're not exactly going to cooperate like we might like. Now, why might that be happening? Well, yeah, we'll want to put them in different places, but look at this one up at the top. This one's just moving back and forth, but it's not hitting the end on either side. Why is that happening? And then these two are just sort of hitting, yep, and then that's game over. Well, they do have the code. That's the thing. They actually have the exact same code in them that the original Ghost had. But there's one thing in particular that's probably really messing this whole business up. What do you think that could be? And this is a bit of a tricky question, but it is sort of the root of debugging. There is one problem that exists in this code that is causing that to happen. And the fix is a little bit, makes things a little bit longer, but the problem itself, it's just the one. Let's put it this way. What happens when a ghost touches the edge of the screen? All right, so he goes out and he bounces back in. Yeah, it's supposed to go the other way and change costumes. How exactly do we make it go the other way? Yeah, I got what you meant, Jolly. Round Jolly. Well, changing Y makes it go up or down, in this case down. But how do we make the ghost, like say it bounces off the right wall, how do we make it start going left again? It's a little bit more than just change X. Look through your ghost code and see if you can't figure out what exactly is going on here. Okay. What about that? What happens when that happens? When X position is greater than or less, greater to or less than, right? Greater than or equal to 215. Greater than, excuse me, just greater than. Checking out this right here. What happens when X is greater than 215? Okay. A little bit more technically than goes out. What in more description, what happens? What like read the code and tell me what happens. 'Cause remember, computers are dumb, so we had to break them down into very easy to digest steps for the computer. Move speed steps and it goes the direction it is facing. Well, it doesn't. So move speed steps happens here at the top, but what happens to speed on that particular part of the code? Yeah, it sets speed to -10, right? Okay, that could be a problem. Why might that be a problem? With one ghost, setting speed to -10 was just fine, and it worked perfectly. However, with a bunch of ghosts, we get this really weird behavior. Yeah, why is it a problem that we have many ghosts? Not quite, because we have it based on position. So the ghosts can go through each other and it doesn't matter. Think about speed specifically. If we change speed to -10, yeah, that's it. There's only one speed that controls all of the sprites. So when one ghost hits the edge, and you can see it as it gets further along, when one ghost hits the edge, it causes all of the ghosts to change direction. And only the ghost that hits the edge goes down. So you start seeing these ghosts get further and further apart because they change direction. And this one on top is just going back and forth. And it's see when this one hits the left hand side, you'll see this one changes direction as well. So what we need to do is we need to make it so that there is a speed for all of the ghosts and a speed for each individual ghost. So let's delete all these ghost sprites, except for our first one. And Yes, hello Kitty. Let's sort of change the code around a bit in our first ghost sprite so that it operates how we need it to. So we're gonna make a variable, and we're gonna call it this ghost with an H speed zombie ghosts, and we're gonna make it for this sprite only. We called it this ghost speed, so we probably want it to be for this sprite only. And we're gonna hit OK. And as you can see, it's labeled up here, ghost 2, this ghost speed. I'm just gonna hide it real quick. Well, we'll keep it visible. Why not? We'll keep it visible. So now we want to make sure that this ghost only moves this ghost speed. But this ghost speed is going to be based off of speed. It's not a little weird. Hopefully that made a little bit more sense. So let's try and do a little math here. So we set speed to 10. That's great. We'll keep that at 10, right? Because this can be our global speed. So our ghost will always be going as fast as the other ghosts. And if we want to make all of the ghosts go faster, we can change the speed value. However, we want to then set this ghost speed to speed. That seems a little weird, right? But wait, there's more. So instead of moving speed steps, we're going to want to move this ghost speed steps. So far, it seems like we haven't really done anything differently. We've just added more steps to a process, right? But here's the thing. What we can do here is instead of setting the speed in these, we're going to set this ghost speed first off to 0 when he's touching sprite 1, so we know that he stops moving and disappears, so we can get rid of this speed. And, whoops, we're going to set this ghost speed to 10 and negative 10 respectively. Well, speed and negative speed. And there's a way we can do that. Well, the first one's pretty easy. If we want to set it to speed, all we have to do is set this ghost speed to speed, right? Just like what we did up here. And we can put that on this one so that the ghost should flip back in the other direction whenever it hits the edge. This one, though, we want to make sure it goes negative speed, which is a little bit trickier to do because we can't just say the opposite of speed. But what's a really easy way to arrive at a negative number? Using math. How can we make a number negative? Yeah, minus. More specifically, let's throw in the minus operator here. If we do 0 minus speed, this will make, so 0 minus 10 is going to be negative 10, right? And there we go. Now we've set this ghost speed to be 0 minus speed. And then in the positive direction, we make it equal to speed. And we set this ghost speed to be 0. Now, the reason why we've done this is because this never affects speed. So the other ghosts will always pull from this value that never changes. And that ensures that one ghost will not change all of the other ghosts' speeds. Let's test it out. Let's add in a bunch of ghosts again. And if we hit play, we see that they all move in unison with one another. This doesn't really look like much because they're all in the same position, but we don't have that really wonky behavior where all the ghosts start sort of doing their own thing and flying around the screen all over the place. And if we shoot, we hit all of them and they all go away. Now let's try changing where they exist. So if we, yeah, it's not running currently. Or do you mean pause like what I was going over to go over something again? Sure. What did you want me to go over again? Yeah, we could do that. Gotcha. Yeah, definitely. Let's get all the ghosts working properly first, and then we can think about putting a timer on it. But here's the thing: the ghosts themselves act as a timer because you want to make sure that you get rid of them before they hit the ship. So yeah. So I might run a counter challenge and say we can do this, but why would you want to put a timer in there? What do you think a timer could do differently? And there may be I'm not just necessarily doing that to be difficult. You could make it harder by speeding them up. So again, I say, what could a timer do that the ghosts can't do differently? And this isn't just to be difficult. I mean, like there could be a specific thing that I'm not thinking of. Why did we change the code and put set this ghost speed to speed before change y by -10? No reason. That's just where I dragged it back. The order could go either way though. So you could have set ghost speed to 0 minus speed and then change y by -10, or you could have it like I have it there, which is change y by -10 and then set this ghost speed to 0 minus speed. Both of them do the same thing. Not technically, but as far as we're concerned, because it happens in less than the blink of an eye. So to our um, from our point of view, there's absolutely zero difference. Um, and that happened to be where the cursor stopped when I dragged it in. It snapped to a different place than I anticipated it snapping to. Seeing other people talking, it just pops up in the question box for me. So unfortunately, there isn't really a good way to do it. I try and read off things a little bit more, but sometimes I can kind of forget to read the question before I answer it. So sometimes there's no context to what I'm saying. I apologize for that. I'll try and be better about reading off the question so that you know that somebody else is talking and that I'm answering their question. Yeah, for sure, no problem, Misha. Your ghost is good. Oh, okay, gotcha. Excellent. Glad to hear that your ghost is working. Definitely. We were just waiting on some other people to make sure that their code was okay. We had a couple of people requesting that Parshot, so I wanted to make sure that everybody was on the same page. Yeah, but it looks like we're good to go now. So let's spread the ghosts out a little bit and make it so that it's easier to tell where they are. And also, so we don't shoot all of them at the same time whenever we shoot into our clump of ghosts. All right, so let's see here. We've got Ghost 2, Ghost 3, Ghost 4, Ghost 5, and Ghost 6. So we've got 5 ghosts because there's no Ghost 1. Let's see about. If we want to take up space in the middle, let's try spacing them apart 25 steps. So we'll keep Ghost 2 in the middle. We'll put Ghost 3 at negative 25x. This is just for testing purposes. So don't follow along until don't follow along until you until I say so, basically. So is this how it's going to be set up for Science Olympiad? They will see a game like this and change the code. Am I supposed to have the same on my screen to be able to try to change the code myself? When you say the same on your screen as opposed to what's on mine, like have you been following along with the the Scratch presentation? Just so I can understand more clearly what your question is. Oh, this is your first one. Okay, so you weren't here for any of the okay. All right, well we've got other videos on YouTube, but yeah, I do try and encourage the students to follow along on their computers with what I'm doing. I apologize, I didn't realize that this was your first a first attendance to this. Um, and as far as the Science Olympiad is concerned, this, I believe, is the first year of this particular competition. It's not the first year for Science Olympiad, but for this particular competition. In previous years, though, for Science Olympiad, what they've done is they've generally had like a couple of different parts to it. There's one part that involves, usually it's done with Arduino, which is a small little, it's kind of like a tiny computer that hooks up to like electrical circuits and stuff like that. And with that one, what they do is they usually give you a little diagram of a circuit, and then they give you some of the code, and they say, it's supposed to do this. What it's doing is this instead. What is wrong with it? And you might want to look at the code, you might want to look at the wiring and see what's wrong with it, but it's all on a piece of paper. And there's no like physical Arduino there. There's no physical computer there with the code on it. Then in the second room, which is the second part of the Science Olympiad, they would have a physical computer and they would have a physical Arduino, and then they would task you basically with a list of small little projects, and they would task you with making as many of those projects as you could in a 30 to 60-minute period, I believe. So it's a little bit of both. This year with Scratch and Progamers, I'm a little bit more hazy on the details because again, we haven't done Scratch before for Progamers, but I would imagine you probably have a similar thing. You might have a first set of questions that's just got sort of printouts of Scratch, and it's saying, hey, it's supposed to do this, and it's not doing this. Why is it not doing this? And you might look at it and go, oh, they use, instead of this ghost speed, they use score. And so it just doesn't work because score is 0 until you shoot a ghost. And so the ghost isn't moving anywhere, or something like that. And then the second one, oh, you were told that the game would be projected onto a screen and the students would need to recreate it. Okay, well then I would take that as gospel then. That sounds like that's coming from a more informed source than me, certainly. So yeah, that would be the thing is okay. Okay, I would go with that then. So that's what it's going to look like. Is you would have a game projected on the screen, and then you, as the students and contestants, would need to recreate it. Okay, good to know. Yeah, you'd want to recreate it on Scratch. Practicing, I think it would be so. How would you recommend practicing with the students? It would be good to um, go through the. So if you go to YouTube.com and look up Young Engineers of Today, we've got our previous classes from the last couple of weeks up there, so you can check out any of the Division A pro gamers. Yeah, sure. So YouTube.com and then Young Engineers of Today. And it's going to be this first result right here, which is it's got the Young Engineers of Today logo and the circular label, and then you've got the two students up here in the banner picture. And as you can see, middle school Fusion 360, high school Fusion 360, middle school, high school. But then we've got down here, 11818 Pro Gamers, I misspelled that, NCSO Division A. And you're going to want to look for these ones. Here's Division A3. The 3 and the 4 and stuff like that, I've just numbered the lessons. So you'd want to start back at Progamers Lesson 1 and then Progamers Division A2. Only one ghost is moving? Okay, well, we can check that out. And so on and so forth. And then you can go with those. And then if you go to Scratch's main page after going through those, well, let's see here, scratch.mit.edu. You go to Scratch's main page, you can check out other projects that people have made. And on top of that, you can then, so we can go here, and then you can see inside, and it will give you all of the code that the person used in order to build this Scratch. Yeah, this one has a lot of nesting if statements, and Scratch is really Scratch really only supports nesting if statements. Um, there are there are other things you could use. Um, you could use ands, and you could stick them together along with ors and nots. Yeah, it is a fair amount of coding. Um, or you could nest together if statements like this. Although generally this can get kind of hard to read, so sometimes you want to make sure that you reduce that as much as you can. Anyway, point being, you can poke into other people's code and see exactly how they try and do something, and you can double click on something, and it will just run that bit of code for you. So I can say when the green flag is clicked, the city you lived in was perfect, and then you can look at the code and see, oh hey, so how exactly does this work? When the space bar is pressed, you change the color of the ball, whatever. Point being, yeah, you can check that out. So those would be two good avenues. Is running through the presentations so that there's that foundation there, and then also looking at other people's. Okay, all right. Well, we'll meet up again on Thursday then, Parjat. Um, yeah, take it easy, and we'll see you then. But yeah, doing those two things will give you a lot of preparation for the upcoming competition. No problem. All right, so um, as far as this project is concerned, we can set the ghosts about 50 and the X apart from one another, and they should form a nice line. And unfortunately, there's no convenient way to do this in the way we have it set up. So your best bet is just to keep one of the ghosts at 0, 100, and then what if one is showing? Did you, okay, so did you set them all to different X positions? Okay, so the reason why only one is showing is because no matter how many ghosts you duplicated, we had them all set to go to X, 0, and Y, 100 right at the very beginning because they're all duplicating this one, right? So they're going to take all of the same code. So they're all sitting on the same spot. And the best way you can verify that is to shoot that one ghost. And you should see your score move up by more than 1 because you will have hit all of the ghosts. But that's just based on what we've been talking about, that's probably what's going on there, which ties into what I was saying, which is you'll want to set the X position on each of the ghosts to something unique so that they're all in a different X position. So what I did here is I set my initial ghost to 0, 100, and then I set the next ghost to negative 50, 100, and then negative 100, positive 100, and then 50, 100, and 100, 100. And what that did is that spaced them all apart nicely. And so they run like regular ghosts, and as soon as they hit the edge, they kind of flip around to the other side. And now I've got 5 ghosts that are all just kind of doing their own thing, heading down towards the bottom of the screen, going after the ship. Now there's a secondary problem that's happening right now, and that is my laser's killing 2 of them at a time, but that has to do with the fact that the laser doesn't disappear, and so it hits one of the ghosts, and then the next ghost comes in and flies into it. So that's something that we can address in a minute here, but I want to make sure at least that everybody's got their ghosts all moving in a nice line. Give everybody a couple of minutes for that and test it out. Just remember, you want to set the initial X position of each of these ghosts to something different. For instance, I have 100, 50, 0, negative 50, and negative 100, and they all have the same Y position. And once you've got your ghost moving nicely in a line, go ahead and raise your hand. Cool. Got a couple of hands up. give everybody just a couple more minutes. Remember, raise your hand once you've gotten those ghosts in an ice line. Okay, so I think the final step here, at least for now, is to have the laser disappear as soon as it hits one ghost. Because again, watching the behavior here, if I hit, I get 2 ghosts that go away. Sometimes 1, sometimes 2, but generally 2 ghosts that go away. And the reason for that, like I said, is because you'll have a situation in which you have 2 ghosts, right? Ooh, spooky ghosts. And one will get hit by the laser and it'll go away. And then the next one will keep flying forwards and it'll hit the laser and it'll go away. So what we need to do is we need to make it so that as soon as a ghost is hit by a laser, both the ghost and the laser immediately disappear. It'll mean that you can shoot the laser again much more quickly, because we're going to put in a little bit of protection on that as well. But yeah. So let's head over to the laser sprite real quick. And what I'm going to do is I'm going to wrap this whole thing in an if-then statement. And what I'm going to ask is I'm going to ask if this is hidden. Interesting. All right, so we're going to do things a little differently. So we've got the if-then, and we're going to introduce another variable. Hooray, variables. We're going to call it laser flying. I'm going to go through this pretty quickly because it is 6:51 and I want to make sure that you guys are uh, are able to at least see this before the end of the class. But also, I want to make sure that you guys have enough time to answer or ask questions. So this is not going to be, strictly speaking, very good right now. But I'm gonna. Nah, I just want it for this sprite. Um, but this is going to go up on YouTube, so you guys will be able to review this again later. So what I'm going to do is I'm going to ask if laser flying is equal to 1. Or excuse me, 0. I want to make sure it's equal to 0. So if laser flying is equal to 0, and one of the things I'm going to do is I'm going to set laser flying equal to 0 when it first starts out. Then I'm going to set laser flying to 1 until it's hidden itself again, and it's going to be set back to 0. So that's interesting. What just happened there? If we check it out, nothing should really change. I still can only fire as long as it reaches the end of the screen. However, what I'm going to add to each of these ghosts is going to have a broadcast a message, and that message is going to be called hit by laser. And they're going to broadcast this whenever they're hit by the laser. This is going to go the same for Ghost 3, and Ghost 4, and Ghost 5, and Ghost 6. And with the laser, whenever I receive hit by laser, I'm going to set laser flying to 0, and I'm going to hide myself. So now we should see that whenever it hits a ghost, the ghost is going to broadcast hit by laser. Doesn't matter which ghost. All of them are going to send this message. Whenever the laser receives that message, it's going to set laser flying to 0, and then it's going to hide itself. And the reason why setting laser flying to 0 is important is because all of this stuff only happens when laser flying is 0. So we can press the spacebar key as much as we'd like, but if laser flying is 1, the laser will not move. We set laser flying to 0 after it's done flying, after it hits a ghost, and when the game starts. So the only time that laser flying should be 1 is when the laser is flying through space. So now we should see, shoot the laser, yep, still hits the top. If I hit a ghost though, it disappears immediately and I can shoot another one. Well, almost immediately. I also need to make sure that this thing, I make sure that it doesn't get hit by a ghost. Like 2 ghosts don't get hit by the laser. What I'm going to do, so this is going to be up on YouTube. I want you guys to check this out on YouTube, but I want to make sure that I have enough time to ask you guys the poll questions, and then we can, once those are done, we can come back to it. But I've only got a couple of minutes because I have to get ready for my next class. So that's why this is recorded right now. This is going to go up on YouTube tonight or early tomorrow, and I want to make sure that you guys have the ability to see it. So I would recommend checking it out on YouTube if we don't have enough time at this particular, at this particular juncture. No, that shouldn't be the case because I'm currently still recording it. But we'll do the poll questions and we'll leave it open for question